I had the good fortune of meeting Aubrey de Grey many years ago in the early age when we were debating embryonic stem cell research, if some of you are old enough to remember that. And I was in Pittsburgh at a conference that was put together by a scientist, Gerald Schotten, with another scientist, Woo-Suk Wong, who is no longer involved so much in our field, and other dignitaries, including Bob Edwards was there, the Nobel laureate, and Sir John Gordon. And I was able to operate for Bob Edwards, who founded the field of IVF, his slides, because he didn't trust computers to show a presentation. But one of my favorite people that I did meet was Aubrey de Grey, who taught me something and discussed something that I had never heard about before or ever imagined, that aging, the inevitable aging, the death, the chronic illnesses that are suffered might be fixable and might be treatable. And at the time, that was almost heresy to hear someone talk about that. But after I gave a talk and later on, Aubrey, a short time later, invited me to the University of Cambridge in the UK, where I was invited to give a talk on strategies of negligible engineered senescence and the societal implications. And my IQ went up at least 5 points by being able to say strategies of engineered negligible senescence. Anyway, Aubrey, who is the author of one of the most important books, Breaking All Barriers, Ending Aging, it was called, hardly needs an introduction. Is one of the great influencers and crusaders for longevity. He's founded and run nonprofits with the sole intention of initiating research on aspects that most educational institutes and commercial companies are not able to take up or not willing to take up. He's a true believer in donor intent, by the way, and he will be providing an overview of this whole conference, speaking about the seamless integration of regenerative medicine and longevity, addressing some of the outstanding questions about aging and when it does begin. Let's have a round of applause for Dr. Aubrey de Grey.
All right. Oh, thank you so much. Oh, I don't need this. I've got a lavalier mic. That's good. Yep, marvelous. Put this back in there. Great. So first of all, Bernie, thank you so much for that very kind introduction. Yeah, I mean, honestly, the amount that Bernie has done for the field of regenerative medicine over the past 20 years, there's no way to describe it. And I'm particularly happy and honored that in his latest work, Bernie is putting even more emphasis on the application of regenerative medicine to aging than before, with, of course, this conference being a huge illustration of that, being the World Stem Cell Summit, probably the 18th or 19th World Stem Cell Summit, but having a much greater emphasis on aging than previously. I think Bernie's mentioned a couple of times that he's now the executive director not only of the Regenerative Medicine Foundation, but also of a new organization called the Healthspan Action Coalition. And honestly, the Healthspan Action Coalition is really set to make a huge difference to the speed with which we bring these medicines against the health conditions of late life, not only through development, but also dissemination to the wider world. Bernie is an invaluable member of this community as a result of his efforts in those ways, and I'm delighted that my organization, the Longevity Escape Velocity Foundation, is in a position to partner closely with the Healthspan Action Coalition. So I'm going to, because this is the first talk of this part of the meeting, I'm going to give something that's a bit introductory, an overview of why regenerative medicine matters so much in the crusade to bring aging under medical control, and why there is such an overlap between the two. Rejuvenation is a word that I believe is the accurate word, the right word to be used to describe the repair of the body, the reversal of the aged state and the restoration of the body to a youthful state. But honestly, it's been a bit of a fight to get that word to be used in that way. When I, shortly after, probably 1 year after I first met Bernie, I was invited to become the editor-in-chief of a journal which at that point was known as the Journal of Anti-Aging Medicine, and I renamed it Rejuvenation Research. Now, that was a name that the publishers didn't really like, and I had to fight quite hard to get it to be accepted. And indeed, I had a couple more fights with the publishers over a period of time, over the years, because they felt that it was hurting sales on account of rejuvenation is all about cosmetics or something. But I think probably about 5 years ago, I was in the position I could write an editorial in my journal whose title was Rejuvenation, in quotes, Reclaimed. Essentially, it was celebrating the fact that companies and conferences and so on were starting to use the word correctly. And so I believe that the word rejuvenation is one that has been reclaimed and can now be used in its correct way. So I'm going to start, as I said, in a rather introductory way. This is a question that I'm asking here that is not asked nearly enough, that is just much more important than people really think. At the moment, of course, life expectancy across the world, and certainly across the industrialized world, is maybe twice what it was 150 years ago. And you think that's still on? Might be. Yeah, if you can just take. Thanks. It's maybe twice what it was 150 years ago. And of course, the reason for that is that we have hardly any early life mortality in the industrialized world. And of course, it's still much more significant in the poorest countries of the world, but even there, the numbers are plummeting. And of course, that means that life expectancy is rising rapidly. So how come? How come we've been so successful against those infectious diseases that used to kill more than 1/3 of babies before the age of 1, even in the wealthiest countries of the world? But yet we've had almost no success, very, very little success, against the age-related diseases that now predominate. Of course, the fact that they do predominate is a cause for celebration, that so many people are living long enough to get to that age, but it's also a huge problem in the sense that, first of all, financially, it's enormously expensive. As was mentioned just a couple of talks ago, more than 90% of the medical budget of the Western world goes on the health conditions of late life, and that's only going to increase. And of course, the expense is a reflection of the amount of suffering involved. The thing about infections is, by and large, either you recover from them or they kill you quickly, whereas the chronic progressive diseases that we are so familiar with now aren't like that. They just carry on getting worse and worse, and your quality of life goes down and down, and it's pretty miserable. So the question is, what's the difference between these two types of disease? And some people think it's just this one, that there's so much that goes wrong late in life. You're not supposed to be able to read this slide, don't worry. It's just to illustrate that an incredible number of things go wrong with us late in life, and of course they all go wrong at more or less the same time, which means that they interact, they exacerbate each other. And that's a huge problem. The sheer complexity has, to some extent, overwhelmed the ability of the medical profession to bring these problems under medical control. Most people think that's the whole story. Actually, no, it's not the whole story. In fact, it's not even the main story. In order to explain what the real reason is why we've been so unsuccessful against the health problems of late life, we need to first of all understand what those problems actually are. And so here's another question that one can ask. One can ask people this. They can say, okay, in what ways can somebody be sick? And if you ask almost anybody that question, then the answer that you'll get will be something like what I'm showing on this table. people will say, well, okay, like, let's see, there's infectious diseases, right? Communicable diseases. That's column 1 here. And then there's congenital diseases, like Batten's disease that we heard about yesterday, for example, and various other things that a very small minority of us are unlucky enough to inherit. And then there's the big one, the chronic progressive diseases of late life, like Alzheimer's and almost all cancers and atherosclerosis, osteoporosis, and so on. And, you know, that's the big one. And then most people will say that way out in the stratosphere, there's this 4th category of a way to be sick, which is called aging itself. And it consists of these rather nebulous, rather poorly defined things like frailty. And, you know, people think that this is just so different from the disease categories that it's like, you know, it's almost off limits to medicine. That's the kind of implication. And, you know, this is a real problem because it's completely wrong. That's completely not true. Why is it not true? Well, in order to answer that, all I need to do is to give you a definition of aging. And there are lots of definitions of aging out there, but I like this one because not only is it uncontroversial when I go through it, it's also something that demystifies aging. It really, you know, lets you see how aging is something that we don't need to view as this weird enigma. It's something that we do basically understand. So what is aging? It's simply a side effect of being alive, just in the same way that the aging of a car is a side effect of the operation of the car. The normal operation of the human body or of any living organism's body generates changes, generates accumulating changes to the body's molecular and cellular structure and composition. And those changes, you know, because they accumulate, they eventually make us sick. That's why I'm using the word damage to denote those changes. The key thing to recognize is that the body is set up to tolerate a certain amount of those changes without any significant decline in function, whether physical function or mental function. So then that's why, even though these changes are happening throughout life, even starting before we're born, nevertheless, you know, people in their 40s or 50s or 60s are pretty much as functional as people in their 20s or 30s. And it's only after that, in late life, that things start to go downhill. The pathologies of late life begin. So now that we have this definition of aging in just 3 words, we can come back to the table I showed you a moment ago, and we can put the correct version up there. If you look at this and you try to recall what the first version looked like, you will see that all the columns are exactly the same as they were before. The only difference between this version of the table and the previous one is the position of that big thick black line. To emphasize that column 3 is actually not different at all in any biologically meaningful sense from column 4. Columns 3 and 4 are both aspects of aging. The only difference is semantic. The column 3 consists of the aspects of aging that we've chosen to give disease-like names to. That's all. Whereas the placing of this black line in the place I have it here also emphasizes that the conditions in column 3 are completely different from column 1. So there's absolutely no reason to suppose that we would in fact be able to address the things in column 3 in the same way, with the same kind of medicine that we use for column 1. And that, of course, is why today medicine against aging doesn't work. Medicine against aging today is fundamentally what I'm showing you here, geriatric medicine, which tries to address the pathologies of late life by directly attacking the diseases themselves in exactly the same way that we would attack an infection. And this is what allows me now to answer the question I brought up earlier. What is really the problem with fixing the health problems of late life? Why is it really so hard? The answer is not just because we have so many things going wrong with us all at the same time. The main thing is that here, as you can see, we are attacking something that is the consequence of something that's accumulating, right? Attacking the pathologies of late life means attacking the consequences of damage. Damage is still accumulating. So pretty much by definition, any geriatric medicine is certain to become less effective over time as the person gets older and gets more and more damage. It's just obvious. Now, I'm not the first person to realize this. More than a century ago, a few people started to realize that this just wasn't going to work, and that instead we had to be more preventative. So they said, well, okay, let's do this instead. Remember here, the goal here is to stop people from getting sick when they get old. In other words, to separate metabolism from pathology, right? To allow metabolism to carry on happening without causing eventual sickness. And what I've shown you so far is that you can't separate metabolism from pathology by separating damage from pathology. So the whole idea of gerontology, which kind of inspired the whole field, was that we could do so instead by separating metabolism from damage. Essentially by making the body run more cleanly so that it doesn't generate damage at the normal rate. Fine idea in principle, and people tried for a while. But unfortunately there's this problem, which is that metabolism is rather complicated. Someone in the audience, my main scientist getting this, is trying to tell me something, but I have no idea what. I can try. People in the audience are apparently having trouble hearing what I'm saying because of you lot. And I must improve my ability to lip read. Anyway, yes, so the point is metabolism is rather complicated. This here, what I'm showing, is a simplified diagram of a small subset of what we know about how metabolism works. And any of you who've ever written software will immediately see that this is the ultimate nightmare of uncommented spaghetti code. But it's not even, it's worse than that, because this is just what we know. This is a simplified diagram of a small subset of what we know about how metabolism works, which any biologist will agree is completely dwarfed by the enormous astronomical amount that we don't know. So, even ignoring the stuff that we don't even know that we don't know. So, it's just not going to happen. But luckily there's a third approach. And this is the approach that I have come to talk to you about today. We can call it the rejuvenation approach. We can call it the maintenance approach. The idea is, remember what we're trying to do is separate metabolism from pathology. We could do it in principle by separating metabolism from damage or by separating damage from pathology, but that's just not going to happen for the reasons I've already outlined. So instead, what we can do is periodically repair damage, go in and eliminate some of the damage that metabolism has already generated, so that even though metabolism is continuing to do that, to generate more damage, nevertheless the overall load, the overall amount of damage that's there will never reach the point where we start to get sick, the point that exceeds what the body is set up to tolerate. And that is what I work on. The analogy with simple man-made machines is a very strong one. This is, of course, a car that's more than 100 years old, and the operative point here is, how did it get that way? How did it survive so long? The answer is not that it was built to last 100 years, not at all. It was only built to last 10 or 15 years. But here it is, and that's purely because of maintenance, preventative maintenance. Its owners fell in love with it, and they've done more comprehensive preventative maintenance on it than your typical car enjoys, and that's why the car is still going. So 20-odd years ago, I decided to crystallize what I've just told you into a panel of proposed interventions, ways in which we might actually do this damage repair, this rejuvenation. In order to do that, of course, one needs to describe what the targets are, what the damage actually is in concrete molecular cellular terms. And this list on the left was my classification of the various types of damage that accumulate. Of course, this is now a fashionable concept. About 10 years ago, a paper came out called The Hallmarks of Aging, which was rather well received, and in fact is by far the most highly cited paper in the whole of the biology of aging this century, and likely to stay that way for a while. But this is what hallmarks looked like before hallmarks were cool, and actually I still prefer my classification. The main reason I prefer it is because of the right-hand side of the table. for each of my categories, there is a corresponding generic approach to actually doing the damage repair. So I talked about cell loss and cell atrophy here. Of course, the natural way to fix that is to use stem cell therapy. We've heard today lovely talks about the ability of certain types of stem cell to rejuvenate the body by virtue of what they secrete. But the original concept, which is very much true in certain aspects of aging, such as Parkinson's disease, was to simply augment the body's natural ability to replace dead cells with cell division and differentiation by putting precursor cells, stem cells, into the body, which would divide and differentiate to replace the cells that the body is not replacing on its own. And I'm delighted to say that one of the pioneers in that area, Jean Loring, is here, and we'll probably be talking about that later on. So that's just one example. I'm not going to go through all the other categories here. I will just point out that for each of these categories, even 20-odd years ago, it was possible to describe ways in which we might be able to address the damage. And that is something that my work ever since has been focused on in each of the various organizations that I've led, and of course by many other people. So one of the best things I'd like to point out here is what I'm writing on the bottom line, namely that even though some of these proposals were really quite revolutionary and preliminary 20 years ago, at this point, every single one of them has moved forward to the point where they're being pursued in the private sector, not just in academia. In some cases, only a couple of companies, but still, that's a great deal better than none, and that's growing all the time. So this is a really good testament to the progress that's been made in actually making this maintenance approach a reality. Another thing that's, there's the Hallmarks paper. Yeah, perhaps they had better graphics than me. No, but the real thing was that, it was a very big paradigm shift to move from what I call the gerontology approach to the damage repair approach. And, I basically, spent those 10 years taking all the bullets and generally making it clear that this was something that had scientific and medical promise. And by 10 years ago, that argument had been won, and it was possible for mainstream people to come out and say the same thing. So I do want to point this out as well, that it's not only that the kinds of approach that I was suggesting for doing damage repair 20 years ago have stood the test of time and moved forward and are now in the private sector, it's also that we keep seeing new, alternative ways to do damage repair coming along. So here I've got the same list of 7 categories on the left, and as you can see, after each of them I have the word now also something. This is really rather remarkable that we now have options for each of these things. Again, going back to loss of cells, the goal here, of course, is to have more stem cells in the body that will provide the regenerative potential that younger bodies, or especially very early in life, have and that is eventually lost. And the concept of partial reprogramming, which has, of course, attracted a vast amount of funding over the past couple of years, is precisely that. It's just that rather than injecting new stem cells, you make the resident cells more stem-like. And that's a very viable approach, which honestly, until Yamanaka came along at least, would not really have been considered remotely plausible. And we can go down the list and look at a lot of other things that are doing the same thing. We've heard a lot about CAR-T today, especially from Peter Marks. And CAR-T was a twinkle in people's eye only 10 or 12 years ago. Certainly when I started getting interested in cancer immunotherapy, the field had existed for a long time, but it had made basically no progress over decades. And suddenly, bang, we've got CAR-T and also, of course, checkpoint inhibitors. And so, it's a good time to be alive if you want to get this kind of stuff working. So what I'm going to talk about now, and for the rest of my time, I think, is what we're doing at Lev Foundation. In the work that I've done in my previous 2 foundations, and that I've overseen, and which is certainly still going on, there has been a focus on developing these individual technologies that are addressing and repairing and eliminating individual types of damage. But as you can see, by definition, this damage repair approach is a divide and conquer approach. In other words, we have to address all of these types of damage, not perfectly, but reasonably well, if we are to expect a dramatic result in terms of postponement of late life ill health. And so the time is now finally here when some of these interventions are working pretty well in mice. And that, therefore, is the point which allows us to start putting them together, to start giving multiple interventions to the same mice at the same time, with the goal to, of course, see synergy and additive effects, or more than additive. And so that's what we're doing at Lev Foundation right now. Our flagship project is being performed at a wonderful company I call Life Sciences in upstate New York, which is led by one of my early protégés. And they're working on 1,000 mice that we bought for them in December of last year. The study began just 3 or 4 months ago, and it consists of combining 4 very different therapies. You see them written down here. First of all, rapamycin, which uniquely among these 4 is not really a damage repair modality. It's really more of a mimic of calorie restriction, but the point is it has got pretty reproducible results in mice, so it was something we really thought we had to include. The other 3 approaches that I'm writing here are very much damage repair approaches. First of all, doing a bone marrow transplant with cells taken from young mice. Secondly, gene therapy, providing the gene for the catalytic subunit of telomerase. And thirdly, a senolytic, a drug that selectively kills senescent cells. So, key thing here is we want to demonstrate rejuvenation. And that means we want to take mice that are already in middle age when we start. We'd like them not to be overtly sick yet, but not to be too far away from becoming overtly sick. And so that means that we're using C57 black 6 mice, whose average lifespan is about 2.5 years, maximum about 3.25 years. And we are not doing anything to them at all until they're already 1.5 years old. Luckily, Jackson Labs are able to provide 1,000 mice that are already 1.5 years old, so that's what we bought towards the end of last year. And so the experiment began when the mice had hit 19 months, and we want to double their remaining lifespan. We want to give them an additional year over and above the 1 year that they've naturally got left. And we'd like to do that to the maximum lifespan as well, so raise the maximum to maybe 4.25 years. And of course, we won't just be looking at survival, we need to look at a whole bunch of markers of biological age. So we have 10 treatment groups with 100 mice in each group. Of course, we have a group that's getting all the therapies. We have a group that's getting none of them. We also have 4 groups, each of which is getting just one of the interventions as a kind of way to validate what has been shown by other researchers for each of these interventions individually. And then we're also interested in making sure that, just seeing whether there are any antagonistic interactions between these things. So in order to do that, we have 4 groups, each of which is getting 3 out of the 4 interventions. So that makes a total of 10 groups. And we're also being rather careful about our controls. Each of these interventions can have 2 types of control. You can actually just not give them the intervention at all, or you can give them an inactivated form of the intervention. So, for example, you can give them the vector with the telomerase gene, but just not include the telomerase gene. Or you can give them the vehicle that you're dissolving your senolytic in, but not dissolve the senolytic. So those 2 versions of the control, basically mock and null, mock and null, we're doing that for all 4 of the interventions. So we've actually got 19 groups, not 10. And as I said, we're looking at health span in all manner of different ways. We're doing the easy, non-invasive measures like visual indicators of biological age, such as alopecia and kyphosis. We're also looking at various behavioral things, memory tests, physiological tests like grip strength. Then on top of that, we're taking blood samples. This is, of course, there's many things that you can measure from that. And for good measure, we are sacrificing some of our mice at various time points in order to do the analyses of tissues that can't be done non-invasively. And all of this will add up to a pretty comprehensive indicator of biological age. One innovation that we've introduced, which seems not to have been done by other people in the past, is the time points at which we are doing all of the tests I just mentioned. So pretty much everybody historically has done this by just picking a series of chronological ages of the animals at which to do such things. We're not doing that. We're taking each group individually and we're saying, okay, let's wait until 20% of that group have died and then we do the test. And of course that's going to happen at a slightly different, well maybe very different chronological age than it will in another group. So, and of course we continue, so we have 4 time points shown here again as being defined in terms of the proportion of mice that are still alive. We believe that this is quite an improvement, and I'm delighted to say that a number of other people seem to agree with us on this, that the signal-to-noise ratio of the information that we get will be better this way. We essentially won't be measuring multiple things that we already know are closely correlated with each other, which is not the way to get the best information per dollar. So we're quite happy with that way of doing things. Just want to talk also about our conferences. So those of you who've been familiar with my work for a long time will know that I believe very strongly in the power of conferences to make a big difference to the world and to the field. And I've been running them since, I think 1 year before Bernie started running his conferences. So I started in 2003. And they've been blinding successes. People have come to them and got into the field for the first time. Many collaborations have happened and so on. Of course, COVID put a stop to all of that, just as it put a stop to the World Stem Cell Summit in terms of in-person meetings. I didn't have one between 2019 and last year, but last year we definitely were back with a bang with the first Longevity Summit Dublin, overseen and coordinated by Martin O'Dea, who is here. And the next one is coming up this coming August, 17th through 20th. Dublin is a fantastic city to have such a conference in. Great place, great party town. Nice place to have a conference that emphasizes the recreational component and the informal interactions, which mine certainly does. So that's it. I don't know whether there's any time for questions, but I'd be happy to take any if there is.
I think we'll have the questions later.
Sure.